Hello friends, let us now take the another method, and it is named as Regula Falsi method, or it is also known as false position method. Okay, so the idea here is, say suppose you have some curve here like this, and this is our exit route. Suppose there is a point A here, and say some point say B here. So here you can see that FA are of FA and A is this point, and this point is B and FB, and we see that FA is negative, FB is positive. In short, FA and FB are of opposite sign. So we are given a continuous function fx where we find a and b such that fa and fb are of opposite sign. It may also happen like fa is positive and fb is negative. Okay, so the idea here is like this: if we join these two points, then it cuts the x-axis somewhere here, and we call this is our first approximation. So that is the idea. Then you can see that here is a point, say x1, fx1, and again we join these 2 points, and then we have the next approximation x2. So by this way we are approaching at our this exit route. Okay, so that is the idea behind that. So how we are doing these things? So we do like this. So we are having some function fx, or so you can say an equation, and we want to find out its root. Okay, so we select 2 points, say x equal to a and x equal to b, such that fa multiply fb is negative, or you can say that fa and fb are of opposite sign. Okay, this function is continuous. So we can definitely say that there is a root in the interval AB. So we have a root in this interval AB. Now it's very simple theory, even 12th standard uh, concept. Line passing through 2 points where it intersects the x-axis, and we can easily get the formula. So this x1 we have like this: x1 equal to a fb minus b fa divided by fb minus fa. This is the way we proceed for the uh, false position, or you can say regular Falsi method. This you need to remember. And then next we find fx1 depending on greater than 0 or less than 0. So suppose we have fa is say, suppose it is say positive, AB is suppose say negative, and suppose f of x1 is positive. So we have like this, there is a root in A, B, and somewhere say here x1, f of A is positive, AB is negative, and suppose f of x1 is positive. Then naturally there is a root lying between x1 and B. So in this case, root lies in x1 and B. Suppose f of x1 negative, then the situation is like this. A here, B here, f of A is positive, f of B is negative, and somewhere x1 is there, and f of x1 is positive. Then the root lies in f of x1, sorry, negative, f of x1 negative. Then the root lies between these two, A and x1. So in this case, you can say that root lies in ax1, and then you can find next x2. Again find x2, then again by this formula, and continue the process. Okay, so this is very simple, and let us solve the example now. Okay, so let us solve the example. Find a positive root of x cube minus 4x plus 1 correct up to 3 decimal places using regular Falsi method. Okay, so here let us see, f of x is x cube minus 4x plus 1. Now f of 0 is 1, this is positive. F of 1, find out here, 1 minus 4 plus 1 minus 2 negative. So you can say that root lies between 0 and 1. So therefore there is a root in the interval 0 and 1. So you can consider this as A, this as B. Okay, this is you can say f of A, this is f of B. So now our next is x1 equal to this formula now, that is AFB minus BFA over FB minus FA. And so here A is what? 0, FB is minus 2, minus B is 1, FA, F0, that is 1 upon F of B is minus 2 minus F of A. F of A is 1, and we simplify, we'll get 0.3333. So this is our f of x1. Now we can find out f of x1, like f of 0.3333. Here this is f of x. You can use the calculator and put this value 0.3333 cube minus 4 into 0.3333 plus 1. You will find that it is minus 0.2962. That means it is negative. So now you have like this. Our A was 0, B was 1. This is x1.3333. Now f of x1 is negative, at f of 0 positive, f of 1 negative. So now you can see that root lies between where? So root lies between this positive and negative. So here. So you can say that root lies in 0.3333. Okay, this is the way. So next iteration. So now this become your A, this become your B, and this is f of B, and f of 0 is 1. So that is our f of A. So this is f of A, this is f of B, this is A, and this is B. So what is the next iteration is x2, and x2 is again same formula, AFB minus BFA over FB minus FA. So this is equal to A is 0, then minus B is now 0.3333 into FA. FA is 1 divided by FB. FB is minus 0.2962 minus FA. FA is 1. So you use the calculator and find this value as 0.2571. 0.2571. And next we find f of 0.2571. Use the calculator again. Here you put this value 0.2571 cube minus 4 into 0.2571 plus 1, and see that you will get the value as minus 0.0114, and so it is negative. Now see, earlier the root lying in 0 and 0.3333. Here f value is negative, here f value is positive. Here we get the point 0.2571 and its f value is negative. So now again the root lies between what? These two. So you can say that root lies in 0 to 0.2571. So again this is A, this is B. So this is f of B, again f of A. So f0, that is 1, is our fa. Okay, so now again the same. So let us take the third iteration, x3. Again same formula, AFB minus BFA upon FB minus FA. So A is 0, B is 0.2571, FA is 1 upon FB is minus 0.0114 minus FA is 1. You use the calculator and you will get the value is 0.2542, 0.2542, and then you take the value here f of 0.2542. So f of 0.2542, fx we are having like x cube minus 4x plus 1. So you use the calculator and you will find that this is minus 0.3 times 0 and 4, and so again this is negative. So now what we have, we had like the root lies between 0 and 0.2542. This was negative, this is positive, and no, root lies in 0.2571, and now we have like this 0.2542, and that is also negative. So now our root lies again between, so you can say that root lies in 0 and 0.2542. This is our B, this is our A, this will become f of B, and f of A we know. So next step is use the formula, that is AFB minus BFA upon FB minus FA. So A is 0, B is 0.2542 multiply 1, then this is minus 0.0004 minus 1, and again you simplify, you will get 0.2541. So earlier it was 0.254, now it is 0.2541, and we are asked correct up to 3 decimal places. So therefore you can say that require approximate root of given equation is 0.254. This is your answer. Thank you.